Yo, what's up, everyone? Back at it with week 4. A normal week, we have a full 5 days, and we'll have 2 problem sets and a quiz. So we're in a groove now. We're still in our first unit, which is linear equations, but we're going to continue to talk about piecewise, and then something you've probably seen before, domain and range. And before I say anything, domain and range is a topic that a lot of students come in struggling with, but I think I teach it pretty well. So you've definitely heard these words and might think they suck or whatever. But if you pay attention to this, they work really well with piecewise, and it's going to be really good. So we're going to start with review. It just says to graph the following piecewise function on the graph to the right, and then second, identify the domain and the range. So if we're trying to draw this piecewise, we see there's 3 different sections, and we have to graph each of them individually, okay? So if this is my first equation, y equals, or fx equals 3x minus 2, this is happening from negative infinity, meaning over here, all the way till we get to 3. So if I'm trying to figure out how this looks, I just need to plug in values to this. So I can actually plug in 3, and that should work, right? Because 3 times 3 would give me 9, minus 2, meaning our first point would be 3, comma 7. Remember that if you have to draw one of these and it's not listed on the y-axis, you can always make yourself a little table. Where what I just did was I knew 3 was one of the options inside this interval, so I plugged in 3. Sorry that's so hard to read. Into the equation, and that equals 7. In this case we have an advantage. We do have the y-intercept at negative 2. Okay, so we could draw that in. And you only need 2 points to make your line. Okay, the slope is 3, so it's going to just go down 3, 3, 3. But as long as you have 2 points, all you ever have to do is draw straight through them. So I still don't have a ruler, so I just use like a magazine I've never read before. And it's going from 3 to negative infinity. So it's going to continue forever. Okay? And this is really important. So once we drew that line in, it's saying it's going all the way to negative infinity. So we need to make sure we draw that arrow. That arrow looks like it's going down, but it's going 2 directions, right? It's going to the left and it's going down. So that signals that this graph will continue forever. And we'll talk about what it will reach for domain and range. So that's the first part. The second part here is 3 to 6, and the function is negative 2/3 x plus 9. And let me just plug in 6 into the equation to see where we're headed. Okay, so 6 times negative 2 over 3, because x is 6, is going to give us negative 4. Okay, 12 divided by negative 3, or negative 12 divided by 3, negative 4, so this is 5. And I do apologize if I'm going a little bit fast through this, but that's because this is the review section of doing this. So sometimes, I don't care if you watch the whole video. If you know how to draw piecewise, you can always skip to when I finish drawing it. But because the slope is negative 2/3, this makes a lot of sense. So this would be my second part. And then finally, it's 5 from 6 all the way to infinity. So if you just see a number, that's a horizontal line at that value. So if we see 5, sometimes this is harder than a whole equation. 5 just means that we are 5 this whole time. No matter what, I'm sorry about this part of the line. No matter what, it's 5 forever, all the way until we get to infinity. Okay, so we drew it and we talked about it a little bit, but now we're going to talk about domain and range. And the key to this does to some degree relate to our arrows, but what we have to think for domain and range is what are the possible x values and what are the possible y values. Okay, so what I mean by that is what is the biggest number possible for x and then the smallest possible number for x. And if we're looking at this graph particularly, we know that this arrow extends forever. So whenever we have like a 10 by 10 grid, what you have to realize is this actually represents like a way bigger graph, a graph that could extend forever. And if our arrow is extending, that means that it keeps going. It keeps going forever. So eventually, what x value will it reach? It'll make it all the way to the left. The end left value is negative infinity. Okay? So the farthest left value here is negative infinity, because my graph will keep going forever this way and eventually hit the end. Think about it the same way on this side. So domain is x, and think that this is our x, right? So it goes to negative infinity, but then this is going to continue forever too, all the way to infinity. So the hardest part of domain and range is we're going to have to deal with infinity signs, but if you see a domain of negative infinity to infinity, that means that all numbers are possible. If you have arrows going both directions, that means everything's possible. If that's a little confusing, we're going to see different domains for the second example, but domain is the possible x values. Range is the possible y values. So think we were just reading it from left to right. Now we want to read it from up to down. So we'll start down because we want to go from the lowest value to the highest value. If you were looking at this, how far is this graph going to go down? It's going to go down all the way to negative infinity. Nothing is stopping this graph from going forever. However, if we're talking about the y values, does this line, let me draw it so it's 100% clear. Does this line go up at all? No, right? It's going to continue to go to the right and never any higher. So what is the highest y value that's possible on this entire graph? We know that this is only going to get smaller for y. This is going to stay 5 forever. So this value, 7, is the highest possible y value. Okay, does that make sense? No point on this graph is over here, ever. There's no way. This is the highest y, or the range, can possibly be. And for now, if you see a infinity, use an open circle, open parenthesis, so like a circular parenthesis, and if you see a number, put a hard parenthesis. We're going to refine this, but hopefully that makes sense to everyone. If we're talking about what's possible on this graph, it can go all the way to negative infinity. It goes this way forever, all the way to infinity this way, so that's x. But then for y, it can go down to negative infinity, but it can never get any higher than 7. Okay, so let's tackle a second question. Okay, so this question is telling us to write the equation given the graph, and then also identify the domain and the range. And I'm going to do the equations second, so that we can talk about how domain and range are purely like a visual thing. So first, what is different about the ends of this graph? If we don't see an arrow, and it's not extending, so right, this line could have kept going, and there's no arrow, that means this is the end point here. Okay? Here, this value is the end point on the left side. We can't have any value that goes past this. So a lot of times, or honestly more often, your graph ends in arrows, okay? If your ranges for your piecewise go to negative infinity to infinity, a secret is that's what's going to happen to your x values as well. But here, our graph only goes from this value to this value. So think that 7 or 8, 7 and 8 aren't possible x values, right? X can never be 7. X can never be 8. X can never be 9, because that's not part of the equation. The equation ends at 6. So 6 is going to be our highest domain. And hopefully everyone understands the difference between these. If this was an arrow going forever, this would be infinity. But because it ends at 6, that's the top of the interval. Now what's the smallest possible value? We can travel up and then down. We get to this value at -3. -3 is the lowest x value possible. So our domain is -3 to 6. Going from this, we can only travel from here to here. Everything this way and everything this way are not part of the graph. Okay, good. Now let's do the range. The range is the same concept, but instead of x values, it's y values. So here, if we're trying to find the y values, we need to figure out what's the lowest possible y value and what's the highest possible y value. So if I'm going to draw this visually, no value is ever going to get lower than this endpoint, right? We don't see on our graph anything lower than this. So we want to name that as -9. And then think it keeps going until we get to this value, which is 7. So if we're trying to figure out what are possible y values, the lowest y could ever be is -9. Nothing is going to go under that. And it's never going to be higher than 7, anything above this point. So the range is -9 to 7. Hopefully that makes sense to everyone. Let's just write out these equations as a quick review so that we can proceed. But domain and range are the biggest part of today, but then also kind of mastering our piecewise are the second part. And our third example will help with the final set of this, but hopefully this makes sense. Our graph goes from -3 to 6 left to right, and -9 to 7 down to up. So if we're trying to figure out our equation, we just have to identify the 3 times when places where things change. Okay, so there's this part of our equation that ends here, and then we start having a higher slope. Then we get to this point, the slope goes down, so those are our 3 ranges. One way to do this that I really like is if the ranges are obvious like this, I can write my ranges first, and then I can write my values, or like my equations. So here, what is this first one? It's from -3 to 1 as the x values. So we can say -3 is less than or equal to 1, x, which is less than or equal to 1. Then, from 1 to 4, things are different. So our second interval is 1 to 4. And then finally from 4 to 6, we have our third equation. So hopefully everyone recognizes that. Crap. And sees what I'm talking about. 3 different equations. We now have to write all of their y equals mx plus b's, but those are those ranges, those intervals. And what's really cool here, and is a good shortcut, is if you have a piecewise, your x values here are going to be your domain. So we've still only dealt with continuous piecewise equations, right? There's no stops, there's no breaks, but it goes from -3 to 1 to 4 to 6, so it goes from -3 to 6. Compared to the first one, think it went from -infinity to infinity, -infinity to infinity. So let's just quickly write these equations. The first one, we can see that the slope is 1 because it's going up 1 into the right one, up to the right one, and then the y-intercept is -6. So if I'm going to write that really quickly, the slope is 1, so 1x minus 6. And don't forget, if you just have a 1, that's the implied number, so you don't even need to write it. A single x, like if it's 1x, it's just the same thing as x. So x minus 6 is this first set. In this second set, let's first find our slope. We're going from this point to this point. You're always looking for perfect points. And we go up 4 every time we go to the right one. So think the change in y was 4. So the slope is going to be 4. Now, however, this is confusing. The y-intercept for this is not actually -6, right? If this line were to continue, actually, it would go all the way here. Because the slope is 4. So if we're going to go left 1, think 1, 2, 3, 4 down. So, you know, we can do the plug-in strategy. That's what we did a lot the other days to figure out this b. But here, because we're so close, I know that this is going to be -10. So if that's confusing you, I keep doing that. Ugh. If that's confusing, you let me know. But again, the y-intercept has to be solved for each different part of my graph. And here, because it's at 1, we just show that if this line were to continue, think what would happen if we continued this? It would get to -10 at 0. Finally, we have to figure out this line. Let's just tackle our slope first. So it's going to go to right 1, but down 1, 2, 3, 4, 5, 6. So it's down now, which means our slope is going to be -6. Finally, we have to find b. And because this is kind of far away from the axis, we can't really see it. I'm just going to plug in a point to solve this. So think to find b here, y equals -6x plus b. We'll plug in this point here, which is 5, 1. And we'll solve b to 29. And whenever you do any math, think if that's logical. And 29 is really logical, because think, where is this line going to touch the graph? Way up there somewhere, okay? All the way at 29. Okay. So this is the last time I'll, identify equations for piecewise, and hopefully at this point we feel really comfortable with all of the ways we can do it. We're crushing it on time. I think it's going to be under 20-minute video. But we're going to do one last equation. And before you do it, draw on these arrows here, because this is really important. And again, I forget if you guys remember from the last time, I've been drawing these on Desmos, which we're going to use for projects later, but it won't give me the arrows right now. So put in the arrows, and we know that these arrows matter in this case because this is extending as far as it can on both sides, right? This stops at 10, this stops at 10 too. So this is our line, and a lot of times when I would teach domain and range in the past, I would start with a line. But domain and range for lines are really confusing, okay? And the reason is, let's just think about what's happening with this line. With our arrows, we know that it's going to extend forever, right? It's going to keep going both ways. This is going to forever go down and forever go to the left. This is going to forever go up and forever go to the right. So if we're looking at this, think that nothing is stopping this line from going forever, -infinity all the way to infinity. Just like our first example, if we see these arrows, that's going to indicate that you go forever in that direction. And it's always two directions unless it's straight horizontal or straight vertical. So this is going to go all the way to -infinity, and this will go all the way to +infinity. And if we want to think about it, what's different about this one, and what can be actually so confusing even though it's the easiest by far, is the range also can go forever, both directions, right? Nothing is stopping this graph from touching every possible point, okay? So a straight line is always going to just have, with arrows, -infinity, infinity for both domain and for range. And think what's different about that than our first example is this arrow, or this line stopped here, okay? Nothing was ever indicating we're going to go up forever. This was horizontal. It's not going to go up at all. So when you have piecewise, these can be kind of tricky, okay? But if you have a straight line, it's actually so simple. It's always going to be -infinity, infinity for both domain and range. And again, think that nothing's stopping this from going every direction. And then, let's just quickly find the equation for this line. Our y-intercept is -7. And our slope is 1/2. Okay, so that's everything I have for you today. I don't think it's too difficult. At this point, all the piecewise equations, all the equations, hopefully you can crush because I went through them a little quick today. But yeah, I think next week we're going to finish the unit, and then after that, we'll have our first test. So proud of you all.